per release of the EMBL nucleotide sequence database or SwissProt to 400 places in the world. That was the user community. Nowadays, the EBI gets per day 125 million web requests and from tens of millions of IP addresses every year. So it's a complete explosion of the whole space. And
the scale of data that you're now curating, I would guess, has also grown substantially.
Oh yeah. When we moved 1994 from EMBL Heidelberg to Hinxton to set up the European Bioinformatics Institute, Peter Stör put the VMS machine in the trunk of his car and drove it over. Yeah? And the amount of data he transported over was around 80 gigabytes. Yeah? So that was it. Nowadays we have something like half an exabyte of disks. So it's quite a lot more. And we had, since the beginning of the 80s until now, still the same situation that around every 18 months the data doubled. And of course the staff didn't double, so you always had to improve the productivity and the sophistication of your software and of your tools to deal with the data. When you had a relatively small and homogeneous user community, then you could tweak and work on bespoke solutions for your communities. But at some stage it doesn't work anymore because you can't scale your workforce in the way that you can build all these bespoke solutions. So you need to see what are the common grounds of all of these different communities. You offer something which is usable by a broad base, and then you make it open enough in data, in standards, in tools, that others can build then the bespoke tools and bespoke solutions, because you're not able to deal with that. And again, that was something where I believe we were also quite successful, because we put a lot of effort into standardization, controlled vocabularies, and in the early days we had not even a sort of taxonomy for the biological species which was shared between databases. If you looked in the mid-90s into a database like the Protein Data Bank and looked for E. coli, then you needed to know all the 17 forms of how it was spelled or misspelled or abbreviated to get all E. coli. And there was not so much E. coli data in there at that time, but even that was a challenge because there was no standards. And then all the databases, for example, came together and said, oh, we adopt the taxonomy which is created by our colleagues at NIH, at NCBI. So I think these international standardization efforts were incredibly important. You know, I was involved in the proteomic standards initiative in a different field. My colleagues like Ewan Birney, who was co-director with me for a long time at EBI, he was involved in the Global Alliance for Genomics and Health, where they set up a lot of standards for genomics. And I think this is so important that we share this common ground and make it open to everyone. That's one of the reasons why molecular biology has become, for me, the lead science direction of our time, because there was this willingness of molecular biologists to share. AI will transform the way we work, full stop. But the importance of experimental data in science and well-annotated experimental data in science is even higher now, because if you want to create good AI predictions, then you need to have training material. And the best example was AlphaFold,
yes,
which wouldn't have been possible without the well-curated data in the PDB, in UniProt, in Magnify, and so on. They used this.
And that's an incredibly important message to keep reminding people. It's not all the credit going to Google DeepMind. It's actually where did they get the training data from?
Yeah, and I think this is now that we put so much more effort on quality. Because if you look into the data which is in our databases right now, you see the usage is very different. Sometimes certain data doesn't get used anymore because there's a better method, and now you don't get better data. But even if the data is of the same type, some data is more used than others. And why is data more used than others? Because it's better quality and it's better annotated, better curated, better information about the data is there. And that is then usually used for computational developments. With AI, it's getting even more important. Yeah? If you don't have a lot of good training material, good curated data, then you can't do that. So this is super, because it's what we always wanted, super good data. But then it enables us also to use these tools that get developed to speed up our processes in annotating other data. So one of the things when we created UniProt, we had one part which was very well annotated and one part which was, we had the translations of the sequences, but you had no experimental evidence. And we developed at EBI methods how to automatically classify data and then transfer information from the well-annotated data to this one. That was, at that time, as good as it could get. Now it's primitive. But now the new methods allow us this to do that even in a more speedy way and with way more good information. And it changed also the role of the curators, hopefully, to make their work even more interesting and productive. Because before they always had to look for the right papers, then they had to read the whole papers and bring it all together, had then to evaluate the quality of the work which was presented there. If all of this can be done already by machines, and that's what's happening and what we use now, then the trained biologists who work as curators, as annotators for us, they can use their brain for the really important things of evaluating all this information, which is already prepared by artificial intelligence in an easily digestible way, and their productivity will increase. So that means we can get more experimental data as ground truth in the database, which again feeds then better prediction tools and vice versa.